Welcome to Knowledge Sharing Video by Nagaraj Patil.
Welcome to NX CAM session. In this session, we are going to see contour surface area, which is recommended for finishing a single area that consists of a well-deserved order rectangular grid of drive surfaces. The first and foremost thing is to create a tool. I am taking existing tool, or you can go for create new tool and select your tool subtype. Otherwise, you can retrieve tool from library. So currently I use this tool for other operation. So it is existing in my list. So I'm taking. Sometime if you want to edit the tool, you have to go here, edit or display. Once you go for edit, you can see the tool diameter, taper angle, length and other descriptions of this cutter. So as you can see here, the value 0.39, as this component is in inches, so all the parameters are coming in inches. If you want to specify, like right now it is 0.3937, means it's a 10 ball mill. If I want to have 12 ball mill, so what I need to do, either you have to calculate with the 25.43 value, or here itself you have to type 12 Intentionally I took this part as in inches, so that you will understand how to give parameters in diameter I have given 12 I said okay. So tool is changed with respect to that, and next time whenever you come here, the ball mill diameter is showing 0.4724. It's a nothing but 12 It's easy to give values even though if the part is in different unit. Next is we have to define drive method as surface area. To give these inputs, we have to go for this edit spun symbol. Specify drive geometry, click and select the drive geometry. So once you select a drive geometry, one may ask, like, continuously if surfaces are there, can I select? Yes, you can, but that should be in tangential with this particular surface, as well as the tolerance should match with this surface. Then only it will consider the next two. Say okay. Now I need to specify cut direction, from where cutting should start, and I have to show the material on top of the surface or below the surface. I have to mention. Before that, we have to give tool position, whether you want on the surface or tangential to the surface. If it is a contour area, then it is preferred to keep Tanto, means tangential to the surface. Then I need to specify cut direction. Here I will mention from where it has to start. From here, if I would like to start, I need to click this arrow. These white arrows are nothing but these are the possible directions where you can select, and you can have start from that particular direction. I can select this. Once I select, you might observe this circle is coming on this direction. It means I have selected this direction. Metal condition I will see whether it is in upward or downward. Yes, it is in upward direction. Here cut pattern you can take zigzag, follow periphery, helical, zig. So sometime if you have exact rectangular part, that time you can take zigzag, as the linear motions are faster than the circular motions. It is preferred to keep zigzag, like while doing facing and other thing we are using this. And here in this case I can take follow periphery, zigzag, helical. It depends on part to part. If it is a dome shape, I will prefer go for helical. So now for this example I will keep zigzag. So how many number of step overs it is taking, either you can give numbers or scallop. So numbers I can mention whatever I want, otherwise I want to keep scallop. As for 12 scallop height will be 0.03. I will keep in always you mention that. Once you give these values, go for okay. Otherwise also you can observe there is a preview option. which you have selected, the drive geometry, how many contact points which are showing on the component. This you will get. Say okay, generate. Can you see here how exactly this has generated? And in some time you may observe as the reach of this ball mill has not up to the end. If you want to enlarge, there are two methods. One, you can give additional drive surface area that you have to select. The other is here itself, here you will get value to be edited. Where I am getting this, in this cut area, I will mention surface area, and I have to increase the value 102. It's in one direction. You, while doing for the first time, you give some values and see where exactly it is implementing. Now you can observe here it has increased 2% of tool. So like this you have to use that existing by default option, cut area surface percentage. From here you can reduce or increase, either way you can do. Right now it is reaching above the 100%. Sometime if you want to stop in between here, then you have to give value 80 percentage, 70 percentage, then it will stop in between. We'll see that also by giving value. Now I kept 70%. Before that you can preview. Can you see? So from this point it is 70%. What I need to do here also, I need to reduce. If you want to reduce it, give here. Here you will get a preview whenever you change any percentage. Right now if I change here, if I give 30%, you can see the preview and a white color line which is covering this area and it is not covering this area. So if I generate toolpath, then it will generate only within this white color boundary. So it's a I want to reduce here at this point, so I need to change there, not here. So I will make again 0 here. You can see it is changed, and once again percentage I am clicking here, instead of 100 I will take 70% here. So yeah, now I got exact change which I am required. So this will cover this much region. Say okay, generate. Like this you have to use this surface area method, and you can use this option percentage surface cut area to increase or decrease the area. Similarly, you have to keep always in process or piece as use 3D, so that raw material will be considered and it will get machined. If you are only using for finishing, it is not mandatory keep use 3D. If you are using for semi finish, that time you have to use 3D. In geometry you can see already we have specified part. If you want to be specific to a cut area, then it is needed. It's not mandatory to specify the cut area, it is up to you. And if you want to do local program by using area, that time you have to specify cut area. Means if you have to divide the surfaces, then you have to consider a cut area. If I want to keep some stock on this, I can mention from here, so that everywhere wherever it is cutting, it will leave that much material for finishing. Tool axis, as it is a 3-axis one, so always it is Z axis. Sometime if you are doing positional machining like 3+1 3+2, that time you have to go for specify vector and specify that particular direction where you want to have in positional axis. As it is a 3-axis, I am keeping plus ZM. Feed and speed I will mention here. So inch per minute is there. I can give like if I know that 1250 is my mm per minute. So what you need to do, 1250 mm you have to click. Calculate you have to do once, automatically it will change it in inches. You mention your RPM. Here I will give it as 5800 RPM. Like this you have to use software. In strategy, if you want to offset, if material is more than 2 mm or 3 mm, if you want to do multiple passes in a vertical direction, then you can have to give part offset. You can see in the image also there 3 passes are coming. You have to mention how much material is there. For example, 5 mm is there, so I will take 5 mm. Multiple depth I will take. Increment value, every time it has to remove 0.5 or 0.25, then you have to give 0.25 mm. Why I am typing 0 mm every time? Because this component is in inches. Like this you have to mention, so that automatically it will take it in inches and it will go up to the depth what we have mentioned. So right now I'm considering this as a finishing strategy, so I don't want to use this, and I will mention 0 here. If you want to extend, you can extend here, and you have to mention how much distance it has to extend. If it is not covering sharp edges which you want to form with this operation itself, that time you have to use extended edges. Sometime if you are doing mold, that your cutter has to pass on the edges or roll tool to the edges, that time you have to keep this roll tool over edges. In non-cutting moves, when you turn on this override with smooth connection, after a pass, whenever it is going to the next pass, it will lift to a certain distance or clearance distance. If you want to avoid that lifting non-cutting moves, then you need to turn on this smoothing option on. Once you turn on this smoothing option, it will ask what will be the height of that connection which is getting created, length and height. Whenever the step over is more than 100%, it will lift to a clearance distance. If it is lesser than that, you can see that green color line passes are there, no? Like that it will create. In avoidance, you can give this from point, from where the cutter has to come, from where it has to start. After doing this complete pass, where it has to go, that is return point. By default, these things are covered in a post processor, so no need to specify. If your post processor is not throwing output of homing, then you need to mention those points. Next comes transfer and rapid. So in transfer rapid, clearance option by default it is inherit. It means whatever you have given in MCS, that it will take as a clearance. If you want to see the display, click here, that plane will be highlighted here. So this is the safe clearance plus plane. Otherwise, if you want to specify your own, you can specify by using plane. By if it is a cylindrical part, then bounding cylinder. You can take bounding box, depends on you. For a safety purpose, you have to give that collision check on all the time, so that it will retract whenever there is a collision. In this image you may observe tolerance, always you keep machining method as finish if you are doing finishing, and accordingly tolerance you need to mention. Once every parameters if you set, then go for verify. Here two things you can do, replay and 3D dynamic. If you want to see the raw material how much it is left behind, then use 3D dynamic. Just if you want to see the tool paths, you can use this option, replay. See how exactly your tool path moves on the surface. And also you can see the feed, coordinate, the other thing. If somewhere if it is getting collided, that also you can validate by keeping this pause on collision option on. If you feel this type of videos will helpful in your day-to-day work, then please like, share and subscribe to the channel.
Thanks for watching complete video. Like the video, which motivates me. Subscribe and press bell icon to get update.